So Terraform. So what is Terraform and why do we use it? So we know Ansible, right? So we have seen some playbooks, we have written some roles to automate the configuration. So the similar way, the Terraform will also bring your infrastructure in a state that you wanted. But the only slight difference between Terraform and Ansible here is, so Terraform is used to create the VMs, create the user accounts, create the groups, and create the load balancers. So once you create the VM is ready. So that will Terraform will take care. So once VM is ready, so inside the VM, you need to configure yum, you need to configure HTTPD, you need to configure some Java. So that will be taken care by Ansible. So if someone asks what is Terraform, Terraform is a tool which we can use to automate infrastructure provisioning. So it is a cloud agnostic. So it can work with Azure, it can work with AWS, it can work with Google, it can also work with VMware. That is the beauty of this Terraform. So you can write, you can instructions in one TF file. So you can mention the providers. If you want to use AWS, if you want to use Azure, it will work. That is what Terraform is. So I repeat, Terraform is an infrastructure automation tool which we can use to automate our infrastructure provisioning like VM creation, VPC creations, S3 creations, and all. So once infrastructure is provisioned, then we can use Ansible to configure inside if required. Okay, that is what the Terraform is. So if they say that what is the difference between Terraform and Ansible? So they are not like competitors. Some people think they are competitors, but they are not. So Terraform is an infrastructure. Ansible is a configuration management tool. They both go together. Okay. So yes, so whatever some of the parts what Terraform does, Ansible can also do it. But still people have a different approaches. Okay. So now let's go ahead and see how does it work. So if we talk about the cloud formation templates, so cloud formation templates is a YAML or JSON format where you are going to put the instructions to create your VPC. So far whatever we have been doing, like spinning up a EC2, creating a VPC, creating subnet, so those can done various ways. The first way that we have been doing is a UI, the graphical user interface, AWS CLI. So where we can use a CLI command line instructions where you put all the information in a command line. The third thing is a cloud formation template. Cloud formation template is the instructions where you are put in a JSON or YAML format. The third thing is a Terraform. So out of all these, people prefer mostly Terraform and then cloud formation templates because that's easy way of handling. Okay, so now let's go ahead and look at the Terraform templates. So what is Terraform is we covered, and now let's look at how do we use that. So let's install the Terraform first. So Terraform has a CLI that you need to install. So it's very easy available. You see download CLI. This is what you need to do it. So I already did it. So I have Terraform conf installed in my laptop. So you can also download and install it accordingly. Okay, so it's very instruction, very easy. You just need to download that CLI and add it to the path. It also has support for Windows as well. Okay, that's about your Terraform. So once you install Terraform, now what we need to do first. Okay, so this is what I am going to do. So I go to desktop. I have a directory already called SUV. Okay, then I'm going to create a directory called Terraform. Okay, I'm just creating a direct directory so that I can keep all the files here, like the way I did for KTS. Okay, so you can verify the version, Terraform dash dash version. This will give you your version. Okay, so remember there is a big difference between 0.12 version and lesser than 0.12 version. There are some lot of changes. So when you're installing the Terraform, make sure that you get more than 0.12. Okay, I think you get latest when you install this. Currently we have 0.14 something working, but I'm using still 0.12, which I did a couple of maybe years or months ago. Okay, so I have now Terraform ready. Let's go ahead and first write our first Terraform module. Okay, so in a VS Code, I'm closing all this. In a VS Code, the best thing is you have an extensions. Extensions mean this will give you highlights. So now you have this syntax highlights, right? Similarly, you can also install the Terraform plugin. So if you have here, if you go to the settings, there is a extensions. So you go here and install the Terraform extension, this one. So what this guy does is this will give you syntax highlight. Okay, syntax highlight. So now this is ready. Now first I am going to create a file called main.tf. So Terraform will have an extension called .tf files, main.tf. Now first thing what I need to do, I need to provide which cloud I am using now. Which cloud I am using. So first thing we need to do is the provider. You need to give the provider name like this. So I'll use the space as 2, not 4. Indian using spaces, 2 spaces. Yes. So before to that, let's see what I have covered here. Okay. The first thing is authentication. This is how you need to authenticate, because AWS, you need secret access key and the access key to authenticate to AWS in a CLI fashion, right? The similar way, we need to export these two variables. So Terraform has so many ways of authentication. So let me also check that one as well. Terraform authentication. I'll also give the AWS. Commands login. By default, Terraform will obtain an API key and save in plain text local configuration file where blah, blah, blah. No, this is a enterprise or cloud. Yeah, let's see this. This is the AWS. Yeah. So first we need to mention the provider. What is our provider is, where he has provided. Yeah. So here we can pass like this: access key and your access key value, secret key and secret key value. So if we mention like this, then what happens? This will be exposed, right? This will be exposed. So anyone can see your secret ID and the password. So that's why we use the export command to export it. So here, environment variable as it. You can provide your credentials via AWS access key ID and AWS secret access key ID, environment variable. So some people mention like this, some people mention like this, but this is a wrong way, because this is exposed. But if you do like this, your keys are hidden. So whenever you execute this, the provider will take AWS. Okay, what I need to do, I need to get the key and secret key. It looks, does he mention here? No. Then he will look in the environment variable. If it finds, then it goes ahead. If not, then it complains saying that I did not find the keys. Okay, so he also said the default region, but region you can specify here. There is no harm. Okay, so now let's go ahead and mention this first. So provider, I'm going to mention the region. So I will use est1. Okay, now let's go ahead and first do that. The first command, let's execute. We need to follow the. Okay, I'll create one more folder here. So I will say demo, or maybe login. I move this into this file. So you have a Terraform folder, login folder. Inside I have a main.tf. Okay. So I am Terraform. I'm going inside the login folder. I have the file. The first command that we need to do is Terraform Init. Init means initialize. So initialization. So what it does? So what it does is, so you see the provider. So provider means AWS. So AWS exposes the APIs. With APIs, it will download all the required APIs for that provider. That is what Terraform Init is going to do. Now let me go ahead and run the Terraform Init. See, it's initializing the backend, initializing the provider plugin, checking for available provider plugin, it downloaded. So it downloaded all the AWS APIs that is required for the Terraform. Okay, this is done. Now if I go ahead and do this, I see dot Terraform. So this dot Terraform contains the API information. So this we don't need to worry. It will be there, all the required plugins. So you don't understand what that plugin is and all, but we don't need to worry about that. Okay, I initialized. So what is next step? Next step is Terraform plan. Plan means it is going to verify. So what you wanted, okay, and what you already have it in the cloud. If you don't have it, it will say, I'm going to add these. If you already have it created, then it compares. This is what you want, but this is what you already have. So if both are in sync, then good. If not, then it will verify, okay, these are the changes that are identified. That is what Terraform plan is going to give you. So let me do Terraform plan. I did Terraform plan. Let's see. It says no changes. Infrastructure is up to date because I haven't added anything, right? I haven't any resource to create. This is what Terraform plan is. And then Terraform apply. Applying the changes. If there are any changes detected, then you will do the Terraform apply command. Okay, remember Terraform init is for initialization that will download the plugins. Terraform plan is going to compare what you want and what is there in the cloud. If both are same, then no changes will be detected. If there are some changes, it says these are the changes. And Terraform apply going to make those changes permanently. Okay, so since we don't have any resources, it is not giving me any changes. Now let's go ahead and create one simple resource. Okay, now what is the, we haven't exported the environment variable set. Okay, remember that. Now let's go ahead and create one simple resource. So probably I might be having, yeah, I think I have some resources, right? We have seen yesterday. Okay, so this is Kubernetes, but we have it in Terraform. Okay, this is the mains. No, I will not authenticate. Okay, already I have this. Okay, AWS. So you see the version. So version here is, so we want the version greater than 2.0 here because the API also has a version. So if you don't mention that, it will always use the latest one. Okay, this is also required, but not mandatory though. That is the authentication. Now second step is EC2. Yeah. So first I'm going to create my EC2 instance. So this is the resource. Okay, let's go ahead. Before I copy that, I'll show you how do we write and where we get this. Okay, so now I go to Terraform site here, Terraform. I'm working on AWS. I want EC2 machine to be created. I go this. So you get to registry terraform.i dot docs resources instances. Okay, now you click this. So it says AWS AMI. It's, yeah, AWS instance. Forget about this. Go to the resource directly. So what it says, AWS instance name, and the AMI that you wanted to use, and the instance type T3 micro tags. That's it. Now let's copy this and use it in our template. This is a provider, right? I'm copying this here. So resource, AWS instance. This is the API that we need to use. This you cannot rename or delete. and this is a web. You are giving a name to that. So generally I put main. Okay. And then AMI. So what is this? What is AMI? What is instance type? What are tags? So these are all the arguments that you can pass. So there are some required arguments and there are some optional arguments. So whatever you see here, so these are required. So optional arguments. So you will see all the optional arguments here. See, you see argument references. AMI is required. Associate public IP address optional. Availability zone is also optional, but we can mention CPU core count, CPU thread per, blah, blah, blah. There are so many options. Okay, so we need the AMI. So I need to provide the AMI ID here. Now let's go ahead and get our AMI. I'm logging into AWS. So I need to create EC2. So let's check what are the machines we have at the moment. So we just have only one machine. That is a Jenkins in stopped mode. That is fine. So now I am going to launch the machine. So I just want to copy the, yeah, I want to create the Amazon Linux. This is the AMI ID. So I'm going to copy this one. Okay, I'm going to use it here. That's it. AMI ID. So instance type, I want T2 micro. Okay, tags. So I'm going to add the tags. So tag is going to be Terraform, and I add one more tag, application is equal to demo. So I have added these two. Now I also wanted to add the key pair as well. So because key pair is important, right? So you want to log in. Now let's go back here to Terraform and see if there is another option for key pair. So let's scan all the arguments here. So AMI, availability zone, if you want, we can add it, but I don't add it now. Now EBS block device, EBS optimized, hibernation, host ID, instance profile, and then instance type, we have used it. This is required. And then key name. So key name of the key pair to use for the instance, which can be managed using the AWS key pair resource. So now I need to mention the key name. Okay, I copy. So there is a I here, key underscore name, right? It says key underscore name. I'm going to give here. So I have a key name already called Mac, I think. Key pairs. So key pair name is Mac. So I'm using the key name as a Mac. Okay. So now I have a AMI, instance type, key name, and the tags. Now if I go ahead and apply, this will create a EC2 machine that using this AMI, this T2 micro, and with this key name. Okay. So remember, so we are not providing the VPC details here. So if you don't provide it, then it will consider the default VPC. If you don't have the default VPC, then you need to mention all those details here. Okay, there will be options for VPCs as well. So I have a key name, right? Monitoring, placement, private IP, secondary IPs, subnet ID, tags, tenancy, user data. If you want to execute something, base 64, volume tags, you see, VPC security, group IDs, all this. Root block devices. See, there are so many options available. So whatever you can do through the UI, you can do the same with the Terraform and the CLI as well. But the only thing is you need to know how to use, where to use. Okay, that's what all it is. Now let's go ahead and create this machine. Okay, so how do we do that? Remember, we haven't exported the environment variables yet. So if you want to check, let's check it. Print env grep minus I. What is that? AWS, right? Say I don't have any. I don't have any, right? So now I'm going to plan it. Now let's see what happens. Terraform plan, this will complain. Error. Invalid client token ID. I haven't mentioned it. So now I need to export it, right? So now I need to create one secret key and the access key. So I go to IAM. Create new groups. I'll probably add a one Terraform group. Policy, I don't know. I'll just give the administrator access at the moment, because you don't give the admin access, but since we're practicing, we need to do that now. I also take that user at Terraform. I just need programmatic access. Add it to this guy. Create user. Get the key. I need to export it, right? Export. What is that? Login details. AWS access key ID is equal to this guy and export. Key is equal to. So we exported both secret key and access secret key. So now let's go ahead and do the plan one more time. Terraform plan. Now let's see what happens. So it found the credentials. Now it is comparing. So this is what your EC2 resource and the key value pairs. So AMI ID, which we have given, there is the ARN, associate public IP address, availability zone, everything we haven't passed. So it says known after apply. So this all the information we are getting. So tags also getting added here. VPC tenancy, EBS block device, enclave option, ephemeral block device, blah, blah. There are so many options. So now it says plan one to add. So one means this resource. So you see this resource. So one resource is adding, getting added. Zero to change, because currently there is no machine having with this information. That's why it says zero change. Zero to destroy. Destroy means nothing to be deleted. So only one to add. This is the plan. So this plan will get out. We can also output the same plan in whatever format we want. Okay. So now not whatever format. So we can take the plan and save it, and we can use it later also. But we don't do that. Now let's directly apply. Terraform apply. So what it does, it again performs Terraform plan and then gives you the changes one more time. So I'm going to add one. You want me to continue or not? So you need to provide a keyword called yes, yes. If we enter apart from any word, it doesn't take it. It says no and then stops it. So I'm giving yes now. Now this will go ahead and create the VM for me. See, AWS instance.main is creating. If you want to see in action, let's go ahead and watch in AWS. So this is my machine, EC2 here. Instances. See, Terraform is pending. This is coming. T2 micro. Let's check the keys as well, tags as well. See, name Terraform application demo, right? And the key pair, what is the key pair we have used? There is a key pair section, the details probably.
You missed it. It's on the top.
Is the top?
One step down. A little bit more, more.
Yeah, so this is a key pair name. See, it is there. So it is getting created. See, that it's running. Now we can also see successful. So now what happens if I apply again or if I do a plan again? Now let's see what happens. It says no changes detected. How it identified no changes detected? Because of the state file. You see the state file? This is very important. We need to keep this safe. We have to keep this safe. Okay, so there are a lot of backends available where we can keep this in a S3. If it is Azure, we keep it in a storage account, right? If it is normal, then you can also keep this in a GitHub as well. But keeping this in GitHub is a bit risky because Terraform cannot guarantee that it will redact the secrets. So there are some key values that stores the passwords and the keywords and the values. So those are sensitive information. So if we keep them in GitHub, people can easily see that. So that's why we keep it in a backend where only few people have access to. Okay. Now let's go ahead and see this. Okay. I'll probably open this here. You can see it properly. So yeah. So version 4, these are all Terraform versions, right? Now mode is managed, type AWS instance. This all the state. So this is the information it is going to compare. So you see the state, instance state is running. Okay, so I want to have a VM created and the status is running. This is what my state file is, and it should have this IP address and it should have this public IP address. Okay, delete on termination true. So you have all these options. So if there is any small change, now let's go ahead and rename this Terraform 1. I say Terraform 1 here. So someone accidentally renamed this. That is fine. Now I'm going to compare it. Okay, let me close this. Now again, do a plan now. Now this will detect the change. You see, it detected the change. It says there's one change. What is one change? We can see. So I have one resource. So you see resource, the tilde symbol, negation. If it means, so this resource is having the change. Okay, that's fine. Then what is a change? So there are no symbol here, no symbol here. Here is a symbol. So inside the tags, application will be demo. The name will be Terraform 1 to Terraform. Because in our instructions, we have tag name as Terraform, but someone accidentally edited that to Terraform 1. So it found the change. It is going to detect and replace it. And also public IP. The public IP is currently having this, right? So in the next, when you start and when you restart the machine, this IP address will be changed. Then what happens? It detects the change and then it tries to overwrite it. Okay, that's what it is. Any doubts on this, guys?
So here for every change, we should give the command as plan,
Yeah,
Terraform plan.
yeah. Because why we are accessing this, so we're just creating only one resource here. That is fine. But if we talk about our structure, so we create VPC, we create one subnet, we create two subnets, we create internet gateways, and then we create NAT gateways, and then we create the route and then update the route table. So all this, so you can write in one TF file, Terraform file, and then you can use it. So now if you want to practice, what you can do, you can run the Terraform, your VPC subnet VM will be created automatically. So once you are done, you can just say Terraform destroy. That will destroy everything. You don't need to do it manually. Okay, let's try to do that as well. So I have this Terraform plan now. So now let me go ahead and apply it again. Terraform apply. So if you want to automate Terraform instructions, then you can also pass a variable called dash dash auto approve. Auto approve means this will automatically consider as a yes and then do the whatever change is detected. This is destructive. So this is only uh, recommended when you are writing a bash script and you're automating the process. In that case, you can use auto approve here. Okay, so it doesn't prompt for a confirmation. You just go ahead and make the change. See, it did not ask you for the permission. It went ahead and made the change. So Terraform 1 here, if I refresh, this will be back to Terraform. So if you want to destroy this, you can just do Terraform destroy. So that will destroy whatever resources you have it. See, one to destroy because you have one resource. It will be destroyed automatically. I say yes, this is gone. Now your machine will be destroyed. See, shutting down.
Here, if we create more terraforms, then we should give the name of the terraform there.
No, so Terraform will what, right? So whatever in the directory is a good question actually. So we are doing the Terraform commands from this. So Terraform login directory. So whatever .tf file it has, it will read all the TF files, make them in a proper required order, and then execute. That's why you have to have a different directory for uh, every stack, I would say. Like if you are working for Jenkins creation, so what you want Jenkins creation? So you want VPC, you want subnet, you want internet gateway, and then you want one VM. So this is a complete one stack. So you would create one directory to create all these resources. We just did only one. So once we do more resources, you will come to know. So let's go ahead and check. Destroy is completed. Now my machine is gone. See, terminated. It's gone. That's what the Terraform. It's very simply. We don't need to do everything. You just write the instructions and do Terraform apply and destroy. That's it. Okay, so now let's go ahead and use more. Now probably I'll go to the examples here. Where are the examples? So we did the EC2 one. Yeah, we also have an output here. What is output means? So output means it will print the output in a variable. Then we can use it later. Variables. So I'll probably cover this bit later, not that required. So now let's talk about variables. So what is the variables and why we are using? So we have now instance type here, variable, key name I'm using a variable, provider, and I have so many options now. See, I increase little bit more. I've added the EBS block now, and I'm also using the variables. Now let's see how this variable works. Okay, I'll create one more directory. Maybe I'll use it here. So now Terraform login is there, right? I'm creating one more new folder. I'll use EC2. Okay, so now I have two folders. I'll go inside EC2. I'll close this one. I'll go inside EC2. I'm creating a file main.tf and I'm creating another file called variables.tf and one more file called output.tf. This is naming convention. So all the variables will go here, all the output variables will go here, and this main contains your instructions. Okay, this is what 3 files I have created. Okay, now first I am going to use the main. So what we need to do, we need to first give the provider. So we are using AWS here, right? So again, I'm going to change my space indentation to 2, right? 2. So I need to provide the region here. Region is going to be US East 1. So it's better that you also mention the version, because what happens sometimes down the line, if somebody is trying to use a less version of API, then it will warn them. Okay. So what is the version we are using now here is greater than 2.0. Okay, fine. Now we know already keys are there. So first I need to write my resource. So which resource I am going to use? So resource I am trying to use is same AWS instance. I want to create the AWS machine. So this is what I need to use. AWS instance. Now I need to give a name to that. So which name you want to give? You can give any name. So if you're looking for Jenkins, you can give Jenkins. But I always use a main because we have only one. Okay. Now what is the next thing? I need to use the AMI. So AMI, we are hard coding it, right? I wanted to use a different one. I wanted to use a different. I want to convert whether it's environment based on environment is whether it is a production or non-production. If it's a production, use this AMI. If it's non-production, use this AMI. I want to toggle it over there. So for that, I am going to taking a variable. I need to mention the variable here. Variable I'm mentioning in here. Okay. I went to variables file, variable. Okay. Which variable you want to do? I use AMI. Variable name is AMI. Okay. This is how you mention the variables. Variable AMI. So you need to pass some values here. So if you want to pass the default values, you can use a default section. So what is the AMI? So you can mention the that AMI which you wanted to use. So variables are many. So this is the one type of variable. Maybe first explain the variable. This is like a string variable. Okay. And then this is your list variable. So where your default means the default values. So you can mention like this, like Jenkins, and then this is Ansible, Docker, and this is your map variables. Prod. So this is string variable. So you can just mention whatever you wanted to use. So string mac. So whenever you use a variable name called string, so this will be used. The similar the way we take in a bash. So bash also you mention some variables, right? Similarly, this is the way of mentioning variables in the Terraform. Okay, this is the string variable. This is a list variable. List means you have a like arrays. So where you mention list of 0, list of 1, list of 2. In the bash, we have seen this, right? We take array, array of 0, array of 1, array of 2. Similarly, so if you want to use this value, then you need to mention list of 1. This will be called. Whereas this is like a dictionary in the Python, like key value pairs. So if you want to use the DR1, you need to use map of DR. Then you will get this value. So map of non-prod, then you get this value. This is how you use the variables. So remember, this is string is used when you have just only one key values. This is list. So if you wanted to use a list and call list of 0 for this purpose, list of 1, this purpose, list of 2, this purpose. The map, like a key value pairs. You want to call key and the value, key and the value, key and the value. This is how you mention. Okay, I'll just comment this so that you guys can refer later. Now I am going to take a variable called AMI. Okay, so I'm going to use a variable, and that default, you can mention defaults here. Okay, defaults are not mandatory, but why we use defaults is in case if this value is not passed, then this will be considered. If someone passes the value for AMI variable, then this will be ignored. It's like a default that we mentioned in the Ansibles. Okay, now I wanted to use for production, if it is a prod, I wanted to use Red Hat Linux. So I'm going to get that AMI. So let me go ahead and EC2, sorry, launch instances. Launch instance, come on. So for the production, I wanted to use this one, AMI. So if it is a non-prod, I wanted to use with Red Hat. No, I'll use Ubuntu. Okay. Clear? So I'm using prod and non-prod, two different variables, which is a map. Okay. So now I can control here. Now I wanted to use one more variable called variable of environment. Okay. So default, I'm not going to take the defaults. I'm just mentioning like this. So I'm taking a variable called environment. Okay. I'll use the environment here. Main. Uh, Okay, so I'll probably cover the environment later because it becomes too difficult for you to understand. Now let me use directly. So AMI is going to, so which AMI you want to use? I wanted to use a production, let's say. Okay, I want to use a production. So what is the production value here? I need to use a variable name AMI of prod. Then this value will be replaced. To refer that, I need to use like this. So I need to refer where variable dot, which variable name you want to replace here, AMI replace name. It is a key value pair dot prod. Then so variable AMI of key prod. So variable AMI of key prod. So this value will be replaced here. This is nothing but this AMI is equal to is variables. This. So there is no difference between this. The only thing is rather than we hard coding here, we are just variabilizing that. So how have you mentioned? We have taken a map variable. That is how the AMI. That is fine. Now let's instance type. The second thing is instance type also mandatory, right? Instance type T2 micro. Even I wanted to control that. So I'm going to use variable called instance underscore type of 0. Let's see what happens here. So what I'm using a variable called instance type and I'm using a list here. So I'll go here. Let me create the variable as well. Variable instance type. It is a list. So I'm going to add the default here. So first I will add a t2.micro and then I would add a t3.micro. So I'm using a list variable. This is like a list. This will be called instance type of 0. When I say of 0, this will be called. When I say of 1, this will be called. Okay, so this is what I have used here. So now I use valid instance type of 0. So T2 micro will be reflected. Then I have a tags, right? Now let me even tags, you can also automate that. Now let me take a tags as well as a variable. So variable tags. Okay, so now I'm not going to give the defaults to this. So if you don't pass the defaults, then it will expect that yes, you want to pass the values for these two. Your Terraform will fail otherwise. If you have a defaults, then it will consider the default and goes ahead. But these two are still defaults are missing. That is fine. So tags is equal to var.tags. It is always recommended that you always use the same argument name as a variable so that you can easily relate to this and it in a proper lines. So now AMI is done, instant type is done, tax is done. Okay, now let's go ahead and run this. These are all the required, right? So we also need a key name. So let me also take a key name as well. So key name also I'm variabilizing that. Do we have a key name here? No. Now let me replace this thing with the key name. I'm not giving the defaults as well. So again, var dot key name. That's it. Now let's check that is a key name, right? I just want to verify. Yeah, it's a key name. So we have got everything ready. Now let's go ahead and run this and see what happens. So this is inside in not EC2, rather it is in the, sorry, it was not in login, but the EC directory. So we have a main, variables and output. So we haven't mentioned anything in output. Let's go ahead and add that later. Okay. Now this is good. First we need to do what? Terraform init. So what happens if you directly execute apply before init? Let's see that as well. So it's asking for the variable key name. What is that key name asking? Because we have used a variable called key name. Have we passed defaults? No. Then it will ask you to enter it. The same for tags as well. Okay, let me enter it here. Tags name is equal to checking something. See it failed. It says we need to init it. So let's init that first. Terraform init. Init is done. Now again do Terraform plan. Again asking for the variables. So it is creating. It is failing because tags are not inappropriate. Okay. Inappropriate value for tags. Map of string required. So it looks like it is not taking, right? So now we are not supposed to actually enter during the standard in. Okay, so we need to automate that by using a variable files. So what are those variable files again? Here. So now inside EC2, I'm going to create a new file called prod.tfvars. And I'll create one more file, new file, nonprod.tfvars. I'm just creating two files, tfvars, tfvars prod and non-prod. Now let me go ahead first update the prod one. Okay, so what is the prod one? So first key name is equal to Mac. So this variable name should match with this variable name. Okay, so key name, I'm passing it as a, come on, I'm passing it as a Mac. Now I have a tags as well. Now let me pass the variable from a file as well. So tags is equal to, it's a key value pair, name is equal to where file application is equal to demo. I'm passing these two. So we can also pass a variables for AMI as well, an instance type also. So if you pass it, then these defaults will be overwritten. Okay, so but we're not passing because already we have a defaults here. But if you don't want these defaults, you need to mention in your prod files like this. So AMI is equal to, so production, you are going to use your own AMI, and the non-prod, you are going to use your own AMIs. So now whatever you pass it here will be given a first preference. So this will be considered over these defaults. If you don't pass these here, then the defaults will be considered. The reason why we provide defaults is we don't want the Terraform to fail because AMI, you would be having a AMI because in your company, people say that all the production, you have to use the Amazon Linux only. There is no issue. And you have to use only T2 micro. That is a thumb rule. So in that case, of course, everyone uses the same, right? So you don't need to pass it. Those type of values, you can variabilize that. Okay, so that is good. Now I'm going to remove this one. Now I'm going to run it. Terraform plan. So we need to pass a variable file hyphen var file is equal to prod.tfvars. So I'm saying that I have the variables inside a file and that file name is this. Now hit the enter. So your Terraform will read the variables from this file. So it found all the required variables. So it did not ask me. So it went ahead and to create it. Want to add. So if I hit it, this will create the variable. So now you see the AMI is getting replaced with this one, AMI 0BE. So AMI 0BE, this is for prod. The reason behind this, in the main file, we said AMI.prod1. So AMI.prod1 is having this value. So when I do the plan, this value is considered. So T2 micro, we have used 0. Key name, we passed as a Mac. On the tags, this is what we have passed from a file. So remaining, we haven't passed. So that's why it is saying none after apply. Now let's go ahead and create one more block device. So you see the block device. This block device is in a block. It is a block, remember? So these variables like ID is this, AMI is equal to, they're all single key value. But when you compare this tax, even tax is also has a equal symbol, but this one is not equal. So this is specific block. So again, we need to create a block and this block expects these keys. Okay, let's go ahead and check our Terraform example for that. I have a Terraform here, no, sorry, here. Okay, it says ephemeral, sorry, what is it called? EBS block device. So it is going to create a new volume and mount it automatically here. Okay, so EBS block device, EBS block device. So optional, additional EBS block devices to attach to the instance. Block device configurations only apply on resource creation. See block devices. So only on creation. Okay. Now let's hit this. This will take you to another section. So this document sucks. So this is the each EBS block device supports the following. So maybe let me come from the top so that you can easily understand. So in the first, it will give you all the arguments that you can pass. Okay, and this EBS block device also some more instructions. So if you click down again one more, so it has more instructions about each block device. It supports all these. So volume size, volume type, and then yeah, these many volumes. Device name. So wherever you see required, you need to mention that without fail. If you don't mention, then it will fail. That's fine. So EBS block device, right? So I'm going to add that. So this is my AMI. No, this is my main.tf. So I'm going to add it here. EBS block device. This is a block. So I opened up a block here. Okay. And then the required is device name. Device underscore name. So what name you wanted to give, you can give. If you want to variabilize, you can also variabilize that. But I'm just using the additional volume here. This is like a name I have given. And then let's check the example what I have mentioned there. So I used, oh sorry, this is device name. Okay, not that one. So device name, this is the device name that we need to add. Sorry, yeah, you're right. Volume size, volume type, what type of you're using. General purpose 2. Volume size, I'm just adding 1 GB. Delete on termination true. So whenever you delete this VM, delete this volume also. If you don't mention this parameter, then whenever you delete the VM, this volume will always be there. So you can reuse for another purpose as well. So this is only required when you're sure that this volume can be deleted. If you talk about the additional volumes, like for Jenkins Home, so we have a VM, we have taken EBS volume and used that EBS volume as a Jenkins Home to the VM. So whenever the VM gets terminated, you still have the data in the volume. Then you can spin up one more machine and attach this volume to the new machine. Then boom, you can have your Jenkins back up and running as it is. So in this case, I'm using delete on termination true. It means this will delete the Jenkins home as well if the VM gets deleted. So that's why you have to choose very particular about this flag. Okay, since we are practicing, I'm put the true here. But when you are really working in the company and you needed data to save for long, the persistent data, then you make it as a false. So you would be having the default behaviors as well. So if you verify this thing, so delete on termination, optional, whether the volume should be destroyed on instance termination, defaults to true. So this will be default to true. If you don't want this to happen, then you need to make sure that set it to false. Okay, that's what it is. So device name is given. Now let me change the device name as he said, /dev/sdg, right? He used, I used SDG. So volume type, what type of volume you are using. So we would be having some here as well. So volume type. So you have standard GP2, GP3 or what? So I put the general purpose 2 value. That's fine. I'm also going to use the volume underscore type ZP2. And then what else we have? Device name encrypted. If you want to encrypt it, this is the IOPS, how much IOPS you want. KMS KID for your KMS encryptions for this. Snapshot ID, in case if you already have a snapshot and you want to use that, then you mention the snapshot ID here. Okay. Tags, it also has a separate tags as well. Now let's go ahead and add the tags as well. Tags is equal to, already we have tags, right? I just use the same tags here. And then throughput volume size. So we have a volume size which is in ZB. Yes, I want the volume size as well. They did not say required, optional. But if you don't mention this, I don't know what is the default volume it will spin up. So that's why it's better that you mention it. So volume underscore size is equal to 1. Let's say just 1 GB is fine because we're testing it, right? And then what else we have? Yeah, delete on termination true, they said, but let's make it to false. And we don't want it to delete it. Delete on termination is equal to false. So whenever you see true or false, so they are all like a Boolean operators. So you should not put them around the braces, but it doesn't harm, but I highly recommend that you don't put that. Okay, just say false. So again, the format has gone. Let's keep it in a proper format. That's it. Now let's go ahead and do it. Now same Terraform plan. Now let's see what happens. It says unsupported argument. So tags are not recommended. EBS volume. But he did mention here tags, right? In the EBS block device, he did have a tags here. Let's see, the tags are not working here. I don't know why. Okay, let's delete this one. Now let's go ahead and apply it. Yeah. Now if I check the EBS block device, so you will have some values here. You see, 1 GB, GP2. Okay, so you also have ephemeral block device, metadata options, network interfaces, root block devices, all this. Now let's go ahead and now let also write some user data. Do we have a user data here section? It is not showing up, but let's check it in our Terraform. Let's search for user data. User data. Yeah, we have a user data. Launching, we know this user data. Now let's check user data base 64 instead. They're asking to use this thing. So let's use this. So it is, man, user data base 64. But he did not mention how to use it. Okay, let's just check user data. So if you don't see how to use this, then what you can simply say, you can Google it. Terraform AWS EC2 user data base 64. So this is not having example. This is not having examples, right? Already we have seen this. But they have a different cloud init config something. Now let's see if they have some examples. User data not running. So this is how they mentioned it. They have used some functions over there. They are using the templates here. Issues. Come on. Oh, he's using the file here. Okay. Cloud config.yaml he's using. I thought it will be very easy that we can mention in a block, but they're asking to load the file and use that. Ah, okay, that's fine. So let's not waste the time. So I have this. Let's go ahead and apply it now. Same Terraform apply minus var file prod tf vars. I would say yes. So this will create the resource. Let's go ahead and check in our AWS. Instances running. It must be creating one. See, it is pending created. Now let's check the volumes as well. So we have taken one more extra volume, right? 1 GB. Let's see the one volume getting created. This 8 GB volume for your root OS and this one volume for your additional volume which we are creating it. See, everything is getting ready. Still pending, still creating. Done. So you have it running and the volume is also attached. So volume 1 attached to this machine. You see at SDG. This is what we have used. This is that. This is how we use it. Okay, so now the same. Now let's enhance this. Okay, little bit. So now we have directly taken this prod here, right? Now I'm going to enhance this. So let me first destroy this and then we are going to enhance it further. Terraform destroy. I would just say auto approve. I need to pass the file name, right? Where file is prod.tfvars. So this is going ahead. So let it go. Now I will go ahead and modify this code. Maybe let's wait for some time. Yeah, it is in memory now. So now rather than I'm using like this, so I'm using a variable called environment. So I go variables here. I have a new variable called environment. I keep it empty. Okay. So here I have a prod, non-prod, and then this section, which is good. So I'm going to edit my main.tf file. So here, rather than prod here, I'm going to change this. Okay. AMI dot this is how I need to mention $: AMI of var dot, sorry, key dot. How do you mention this? Var dot environment. Yeah, I think we don't need even this thing. Yeah. Now what happens here? So var of AMI, and then I'm using of here of var dot environment. So here in the variables, I am editing these variables. Oh, here in environment. So if someone passes prod, then this will be considered. If someone passes non-prod, this will be considered. So this is what I am going to toggle it. Okay, so rather than I'm hard coding the prod and non-prod all the time, if they say prod, this will picked up automatically. If they say environment as non-prod, this will be picked up automatically. So I'm using some more automation around the variables here. Okay, so I go here. This is how you mention it. Okay, again instance type. So now instance type, I want to condition. I want to put some if conditions here. So what are the conditions I am going to use? That is called the interpolation in the Terraform. Okay, so here I am going to use the inline variables. So thing is, so maybe I'll copy this first instance type here so that you guys can understand. So this is my variables. Okay, so now I am going to replace this. This is what I have currently. I am going to change this to this Terraform type var dot instance type. Okay, I am using 0 all the time, right? I wanted to toggle between 0 and 1. So I'm going to put the condition here. What the condition is? Var dot environment is equal to production question mark. That is a condition. If it is production, then use var dot instance type of 0. If not, then use var dot instance type of 1. This is the condition. So means if var dot environment variable you passed as a production becomes true. If it's true, then do this. What is this? 0. So take this value. If it is not a production, then use this value, T3 micro. This is what I have mentioned here. So this is the how you use the conditions in a Terraform. Okay, so now I remove this one. Now even the key name and also tag name, tags, perfect. So you can also add the tags as well, update the tags as well. So now EBS block is same, everything is same. Perfect. Now let's go ahead and run this again. This will work as it is, no issues. So environment is here. So now in the var file, I can just simply pass the environment here. Environment is equal to prod. Whereas in non-production, non-prod var files, I'm going to pass this as a non-prod. So you can control your environment properly. So now you can have a production or non-production stack. Okay. So you can just simply say Terraform plan. So you can just say plan. What happened? Okay, okay, yeah, I did not delete it that right. So already I have this, I need to delete this one. See, it's working. So it's replaced it everywhere. So environment is prod, so it is in 0B2. So T2 micro, it is a prod, it is in T2 micro. So if it is a non-prod, you can also do the non-prod here. So I'm using non-prod variable now, not the production variables. If you do, you will see T3 micro, and this is different not 0BE, rather different. Let's see that. See, I ran it again, want to add, see, T3 micro. And then this is different AMI 088B because it's a non-production, right? So this is how you can control the environments with one simple variables and the files. Okay, so remember this is very important about this TF vars. Okay, so you have many places to pass, so you can write the file or you can also pass during the command line itself like this. So Terraform plan dash var means variable. So which variable you are writing? Instance, not instance, key underscore name is equal to something something. We can also pass it like this, but generally this is only useful for one variable file if we have. But if you mention like this, then you don't know what to pass here, right? That's why it is always recommended that even though it is one variable or multiple variables, you create the TF vars files and keep it over there and check your code into your GitHub so that people can easily understand that, okay, I need to pass this TF vars variable and this TF vars differentiates between what they are used for. Okay, so you can also do like this, but I don't recommend this using. You always use the TF vars. Okay, so now we have it. So any doubts on this variables and the resource creation before we jump on to create more resources? Hello?
No, Lokesh.
No, right? Okay, so we done with the EC2 now and the variables and the variable usage map and the conditions, the interpolation. Now let's check, see what else I have here. So we haven't covered the output, right? So let me also add the output here. So what is the output means? It is going to take the variables. So instance private IP address. So here you have this instance private IP address, right? Private IP, it's private IP. Yeah, this private IP, whatever it comes after execution, this will be stored in a variable called instance private IP address. So output, the variable name that you wanted to take. What is the value? Value is equal to AWS instance. This is your resource, AWS instance dot main. So dot main and then private IP. So whatever private IP comes, this thing will be stored in this variable. So that variable we can use it later for other purposes. So if you have other resources are waiting for this output value, then you can also use it. So I'm using the private IP address and the public IP address and the instance ID is here. Okay, now let's go ahead and apply it and see what happens. Okay, so I use the production one. Why I'm doing plan? I would have done the apply directly. I would say yes. Yeah, let it gets create. Come on. Yeah, it is done. You see the outputs, instance ID, public IP address, and the instance private IP address. It is printing in your console, but we can also use the same output for other purposes as well. So now these can be accessible with these variable names. So that's what your output is. Okay, not only just print, we can use for other purpose as well in the modules. So now we have got this. Perfect. Now let's, I think it's 9:30. So what do you guys say? We will stop here and continue next week, because what else we have now is variables are done. Or did I use many variables here? No, I just put everything in one file here. It's up to you. It's up to individual how they wanted to create it. Okay, so here I have used everything in one variable, I mean one file. So this is a variable file, and then main your provider file and the output instructions. But this is a bad practice. So you have to always use a different file names so that you can easily understand in which file you have put what. Okay, so this makes your file bulky and not good to read. That is the one thing. And then 04 variables also I have. So yeah, the same thing I have divided here. So where's output and the main. So in the main files, the same thing. So whatever we had there, I put it here. So remember, I mentioned like this: $var.ami, $var, curly braces, and here. So this syntax is allowed. I mean, this syntax is expected before 0.12, I think. That's why you may see people using this, because this is created like what? Yeah, like 14 months ago, it looks like, right? So it was working that time, but now this is changed. So we don't need to mention this curly brace and the dollar symbol. So that's why I haven't mentioned anywhere. See, I just put direct var.ami of this, var.keyname, var.tags. But before that, we used to mention like this dollar symbol. So this is gone now. So if I execute this file, it will fail. It will complain. It will provide the warning saying that, hey, dude, you are still using the old deprecated syntax, but it will still work. But if you are writing the new YAML files, do not, new TF files, do not mention this. Okay, that's what the variables. And then what else we have? Oh, we have conditions. I think we just covered the conditions now, right? Yeah, so we have the private and the public here, availability zone. Yeah, I have taken the condition here on the availability zone. So you want to create in private subnet or the public subnet. If it is a prod, then I'm creating private. If it is not a prod, then I'm creating in a public subnet. It's a good example. And then what else I have here? Loops, yes. Loops, yeah, you see the count here. Perfect. Yeah, so this is how we use the loops. Loop means if you want to create a same resource two times, like you wanted to create the same machine two times or three times, four times, then you can use the count here. Count is equal to 2. So maybe let me example this. Maybe loops. Let me check this example as well, what I have mentioned here. So this is a good example. I'm using users, AWS. I am user here, type 1. Yeah, this probably will, yeah, loops will cover in next class, because it's a good example of the loops I put there. And the data sources, yeah, data sources. So yeah, data source is also important. We will cover that in next example. And then modules, yeah, project. This is your project. What I'm doing here, I'm creating a VPC, creating internet gateway, creating a subnet, creating one more subnet, and these are all the route information I commented. Default route table I'm creating, and the route information, route table association, AWS instance. You see, so if you don't have a default VPC created, then creating this is not easy because you need to have first VPC. So we are creating a VPC here, and then we are creating internet gateway and attaching it to it. We are creating a subnet, public subnet, private subnet, and then I'm associating up to the route table, and then I have a route table association here, and then AWS instance. So these are all the required. So which we are creating here. So let's see this. Let's see this in a next class. This is very important, guys. Okay. It is like a module, but I put it in a project. Okay. I'm using all the okay variables here. And then VPC main.tf VPC and the yeah, this we need to explain and then we need to go there. Perfect. Modules are there and then examples of IAM. It is attaching the policies. Okay, perfect. I have a mains here. Project main here. Then main.tf. Perfect. Yeah, we will discuss the remaining stuff tomorrow. I think I have already documented very well about the modules and all and some other structure. So any doubts on this, whatever we have covered so far? I'll just destroy this now so that I don't need this. Hello?
After
Hello?
practice, we'll
Allocation.
Yeah, this is very easy, trust me. So Terraform is not that difficult. It's very, very, very easy. So you have everything in the Terraform site. So if you want to create the S3, so you don't know how to create, you just go to Terraform, AWS S3, that's it. Then you see S3 bucket, examples are here, Terraform documentation. So then you will see their information, how to use it. So you have an example here, how to create. This is a private bucket with tags. So you need to use a resource. The resource name is AWS S3 bucket. So you cannot do anything. You have to use it as it is. So here you can change the name of it. So bucket name, and the ACL, access control list, private, and the tags. That's it. So if you want to host static website, so first you need to create a bucket. This is the bucket name that you are giving. ACL public read policy. So you need to copy the policy.json file, the file name, and then website section, index document, error document, routing rules. So routing rules, he is copying some policy directly here. End of file. You mention like this. Boom, you would have your bucket ready. This is something about course, and if you want to enable the versioning, how to use it, this is a block. So these blocks, what to add, what not to add, if you go down, you will see that in an argument section. Arguments references. So bucket prefix, ECL, grant, policies, tags, force destroy, website, versioning, logging. So logging was not there, but someone said you need to enable the logging. So they say setting up bucket logging documentation here. So go to here. I mean, not this guy. I don't know why it taken to this one. So you click on the logging. Sometimes it doesn't take you to the right place. Again, try to search for the logging here. So not this one, this one, this one. So the logging object has this. So target bucket and target prefix. So if you use a logging block, then you need to have a target bucket as a required one. For S3 logging, you are using again S3 another bucket or same bucket. So again, lifecycle rules also here. How you want to enable, what to enable, all the details are here. It is very easy, but the only thing is you need to know how to reference it, how to get that. So you would have a lot of examples on this as well. So you will definitely be asked for Terraform skills. So now you know a bit of Terraform. So what is Terraform? We covered. Why do we use it? We covered. How do we use it? We are covering. So we did the main.tf, we did variable.tf, we did output.tf, and we have seen how to mention the list variables, map variables, the string variables, and how to use them. We did what is the initialization, what is plan and what is apply, and how do we pass a variable files, and how do we differentiate the files between the environments. Okay, so we did a good good cover of Terraform. So next class we are going to discuss on the loops and then the modules. So modules are very important the same way. So whatever we have written now in a output file and the main.tf file and the variable.tl file. So if someone else wanted to use the same, so whatever they want, create a VPC, create an internet gateway, create subnets, create route associations, and then create the instance. So these things is common across all the projects. So you can also share your Terraform scripts with them. It is exactly similar to what we do in Ansible roles. So we write a role and then we share it. Similarly, you write a module and let other people use it. That's what the Terraform modules are here. We'll discuss that in next class. So I think we are good for today. So if you guys don't have any doubts on the Terraform, so we can wrap up, then meet next week. So by next week, we would have the Terraform classes also completed. So after that, we can, not a weekend, so the weekday is possible for everyone. So we can at least have a daily catch up for half an hour or 1 hour to discuss on the interview process and all. I will also have some other folks so who are into the DevOps to talk something on this. Okay. I will also try to get someone, if possible, try to get someone who actually are trained on DevOps, who were actually zero in DevOps. So how they survived, how they managed their story as well. That will give you some boost.